Welcome back to part 2 of the gold-plated silver jewelry refining. We're going to begin this by I'm going to transfer these foils. Here's our gold foils, man. Things look fantastic. All the silver's been rinsed out of this, most of it anyway. So what we're going to do is I'm going to take our filter, put it in this melt dish, and then we're going to incinerate these foils. Get a quick look at the foils. Alright, I'm going to pull the whole filter out and just put it right in this melt dish. Look how clean that Buckner funnel is. That's the benefit of having this filter that rides up the sides. And in the past, I've skipped the incineration part of the process here, and whenever I skip incinerating at this point, when I've got the foils recovered, I always end up with less of a yield than I was expecting, and the gold is dirty when we get it in solution and precipitated. So I don't know why that is, but I'm gonna incinerate this material before we go to the aqua region. I've got our gold foils in that melt dish, filter paper and everything. And what I've done is I've set up my Franken oven out on the back deck. I've got it sitting on a piece of refractory brick to insulate it from underneath. I've taken the cover off of this thing and I've installed ceramic wool all around the oven to insulate it so it can get up to temperature, and I've defeated the thermostatic device so it stays on and it'll get up to about 800 degrees. As I was checking the temperature to see if it was on, the filter paper burst into flames. I set this up outdoors because I knew that there would be some smoke production, and I didn't want that smoke filling up my shop. This is a shot of my electrolytic silver cell. This thing runs 24 hours a day. Look in there, you'll see I've got some pure silver crystal growing in there. So we'll have to do a harvest on that one of these days. I feed the impure silver shot, which is what this is, into an anode filter basket, pass an electric current through it. This basket, with a filter in it, is suspended in silver nitrate electrolyte down there, and the silver ions travel through that electrolyte and then plate out as absolutely pure elemental silver crystal on the inside of that stainless steel bowl. I've got the stainless steel bowl connected with some clamps here to a power supply, and that's the current flow that we have going to the cell right now. It's getting kind of low, so what I'm going to have to do is take some time to clean this cell out. Okay, now we're going to remove the blue solution off of our silver chloride, siphon it off into this bucket down here. We've got a tube full of water. Move this beaker down here, and we'll just siphon off this blue solution. It's going to be a waste solution. This is tap water in this tube. Bucket is a waste bucket. I've got some boiling tap water here. What we're going to do is use this hot tap water to rinse all the blue liquid off of our silver chloride. Here we go. Here I'm using hot tap water to repeatedly rinse the silver chloride. I'm trying to get all of the copper, the blue solution, off of the silver chloride so that when we do the conversion with lye and sugar, no copper will be present. I probably won't be able to get it all, but this will show you how this rinsing process progresses. You can see here the rinse water. It's just a pale blue color now instead of that bright blue color it was earlier. And we're going to give this a couple more rinses. I've got the some water heating up in there, and then we're going to go for the conversion from silver chloride to pure silver metal with lye and sugar. Got some fresh tap water here, hot tap water. It's better to do multiple small volume water rinses here rather than large volumes of water. The small rinses get the copper out of there more efficiently. Here's our fluffy white silver chloride. It's got a little tint of blue to it from the remaining copper in there. If we wanted to go to 3/9 with this, we'd keep rinsing, get all the blue color out of there, and then we'd keep testing our rinse water with ammonia. When you put ammonia in the rinse water and it turns blue, it means you got copper in there. We keep rinsing until the ammonia test remains clear. And this would be absolutely pure silver chloride, and it would make us some nice 3/9 fine silver. Got about 2.5 gallons of waste down there. It's gonna have a little silver chloride in it. I'll let that settle and get that out of there and add it to a silver jar that I have set aside for excess silver chloride. I did one more rinse off camera, and now we're ready to do the conversion to pure silver with lye and sugar. But before I do that, this is one of my brand new beakers. It's nice and pristine, and I'd like to keep it that way. This is one of my older beakers, kind of scraped up on the inside. When we put the lye in here to do the conversion, lye will tend to etch the glass, and so what I'm going to do is I'm going to transfer the silver chloride out of this beaker down into this one. All right, successful. Got a little bit of water in here with this. Rinse the sides down. And what we're going to do now is, I've got a little mixer here, handheld mixer. It's got a little blade on it. See that blade right there? And this thing does a fantastic job of stirring our silver chloride for us. Otherwise, if you try to do this by hand with a stirring rod, it takes forever. You never quite get a complete conversion to silver oxide. So I've got some lye here. What we're going to do is add the lye to our silver chloride while we stir it and convert the silver chloride to silver oxide. And what we're looking for is a real black color to form inside this beaker, from white to a dark black color. Here we go. reaction creates a lot of heat. Got this solution or the mixture up to 178 Fahrenheit, 81 degrees Celsius. We're still not quite done. It's still a brownish color. We're looking for a black color here. It's getting pretty close though. I'm gonna add one more scoop of sodium hydroxide here. And then we'll mix this up, see what we got. Yeah, that's getting there. It's turning it nice and black. That's what we want to see. Blender really helps. If we had to sit here and do this by hand, it'd be a nightmare. Mixer out of the way. Now we're ready to add some sugar to this. Do the conversion to pure silver metal. That's quite a bit of silver oxide in there. It's up to about right here. And this next reaction is highly exothermic. Got regular old sugar here. I'm going to start adding some sugar to convert the silver oxide to pure silver metal. See it turning? From black to gray. Coating the outside of the or the inside of the beaker there with silver. Pretty neat looking. It's starting to boil. Stuff can take off on you in a heartbeat, man. You really got to watch it because it gets really hot, over boiling. I've seen it get up to 230 degrees before, so you got to really watch out adding this sugar. I don't think it's complete yet. I got to put some more sugar in here. Here we go. Add some more sugar. A little bit, a couple tablespoons maybe. I don't know what the chemistry is behind this. We've got some knowledgeable chemists out there that could share what this is, what reaction this is. See how that wants to boil? Don't watch it, it'll come up over the top of that explosively. You know, there's people that see my videos where I demonstrate this, but you gotta watch it, man. Stuff likes to boil hot. silver on you in a heartbeat. Yeah, it ain't done converting yet either. I can still see black down there. Which is kind of concerning. See how it's boiling all by itself? It's 101.6 Celsius, 214 Fahrenheit. I mean, it heats the water above boiling. I'm going to add a little bit more sugar. I don't think it's complete yet. Just a couple tablespoons maybe. Still boil this over, so we gotta watch it, man, adding this sugar in. This is another reason I don't like doing this. You gotta sit here and babysit it. Alright, I think, oh no, there's still some black down in there, man. If you look down here, you'll see that we got some bubbling going on right there. And there's still some reaction going on right there. You see different colors of material. It's getting there though when we add the small amounts of sugar. So we're going in the right direction here, and getting this silver converted to, or the silver chloride, silver oxide converted to pure silver. Yeah, I still see something weird there, man. I'm gonna have to add some more sugar. A little bit more. Yeah, there goes some kind of reaction. Fahrenheit, 96.2 Celsius now, so the temperature's cooled off a little. Alright, I think we're past the point where we could get a runaway reaction. I'm going to add some more sugar. Precipitated now. We got the silver out of our solution. I mean, we've got the silver oxide converted to pure silver metal with some sugar. And we're going to let this settle, pour off the waste solution, and get our silver metal out of there. All right, if you notice here, we've got the silver settled out on the bottom. We've got this red material forming on top of it. Red is probably copper hydroxide. So what I'm going to do is I'm going to get that poured off of there and get this, a little bit of the silver go with it. Get that later. If I leave that copper on there, it'll settle out on my silver. Contaminate it real bad. That's the pure silver metal there. Gray silver powder. Here I rinse the silver off with hot tap water over and over to try to get all of the lye and sugar rinsed off of the pure silver powder. Got about 2.5 gallons of waste that I've poured off. of this silver in here. I'm going to take a piece of pH test strip here, check what the pH of the water is, and you can see it's up around 10. So I still got a lot of rinsing to do here to get all of the lye and sugar off of this silver. This container right here is full, so what I'm going to do is I'm going to pour it off into a separate container. This is the waste from the silver chloride. It's 2.5 gallons. This is 2.5 gallons of lye and sugar waste. And this is the reason I really don't like using the lye and sugar method, because it does produce so much waste. A little bit of silver left down in the bottom there. Hot tap water here. Again, it's better to do many small rinses rather than fewer large rinses. Let it settle out a little minute. All right, I've got all this waste, 2.5 gallons, about 2 gallons of lye and sugar waste. Here's another half a bucket of rinse water that I've been pouring off from our silver. I've just been rinsing this continuously with hot tap water. A little bit of the silver gets poured out every time I do this, and there'll probably be about 1 ounce of silver in the bottom of this bucket when I get done. Give it another quick tap water rinse here. Alright, I'm going to do another quick pH test here on this final rinse. See what we got. That's still just a touch on the green side. It's probably between 6 and 7. So we got most of the lye rinsed off of there. Now what I'm going to do, pour the rest of this rinse water off. We'll get our silver into a melt dish and melt this a nice bar of silver out of this. Time. There's about 2 gallons of waste here. Another 2 gallons of waste, lye and sugar down here. And I got about 2.5 gallons of the blue liquid from the silver chloride waste. So I got over 5 gallons of waste recovering this amount of silver, which should be right around 10 to 20 ounces or so. All right, here we go. We're going to try to get some of this silver down in this melt dish. See if we can get it over on the melt table and melt this up into a fine silver bar. This silver will be very close to 3/9 fine. We could get it to 3/9 fine by rinsing it a little better than we did. Get all the copper off of it. I didn't want to waste a whole bunch of it. It takes a lot of time and effort to do that, and trying to expedite the production of the video here. So we're going to go with this amount right here of silver. Still got a lot left in here, so we'll make 2 bars out of this maybe. Put this over on the melt table now. We're going to start melting this up. I've got my mask on here, so I'm going to talk us through this segment of video here when I do this melt. That silver is sopping wet, so I'm using those 2 torches to dry it out so we can get it melted. Here's the view of the metal through the visor that I set up to protect the camera lens. You'll see there I put on a second visor to protect it from the bright light of the oxyacetylene torch there. And as I was doing the melt, I realized that the mold that I'll be pouring the silver into was on the opposite side of the melt dish here. So in a second you'll see I'll stop the melt, and I left the footage in of where I take the set apart and reconfigure the set over to the other side there so that we can view the pour of the molten metal into the mold. Here I'm 180 degrees opposite of where I was when I started the shoot here, and I'm melting the metal, and I wanted to get the view of the actual pour into the mold. Here we go. There's the pour. All right, we got the molten metal poured into the mold now. I'm going to let it cool off, and then we're going to get it out of there, douse it in some water, and take a look at that beautiful silver bar. All right, that water, there wasn't much in there. It was a little bit warm when I stuck my hand in there. But here's the bar, and if you notice, it's got a little bit of trash on the surface. That may be part of the melt dish that melted and carried over with the pour. All right, we got one silver bar poured here. Try to get the rest of the silver into this hot melt dish now and do the rest of it. See if we can get another bar made up. Putting the wet silver in that hot melt dish caused it to spatter. I should have waited a little longer until the melt dish cooled down before I added that silver to it. Alright, there's still some silver down at the bottom of this beaker. Probably about an ounce. Just take this silver on the table now and melt it up. This time I remembered to set the camera up on the correct side so we can watch the pour into the mold. Here in a second you'll see the torch go dark. I'm lighting the MAP gas torch and directing it onto the mold to preheat that mold before we pour the molten metal into it. And here in a minute you'll see I just bought a new torch head. And I think the configuration, the gas is coming out of there is a little different. Here you'll see the metal appears to be boiling in the melt dish. That's just recently started here. I think it's getting, what's happening there is the oxygen's getting absorbed into the metal, and then it just spits it back out and causes it to look like it's boiling. Anyway, here is our finished bar. I forgot to put more water in that metal container, and when I poured the bar into it, the water in there is already hot from the last one, and it's pretty doggone hot this time. When I stuck my hand in there, it kind of almost burnt me. So here's the nice bar, second bar of pure silver. Let's go ahead and get the last of this silver down into this melt dish now. I'm going to pour it in. I'm going to have to use a squirt bottle to get the rest of it out. I'm going to have a pool of water in here. That's okay. At least we can get a yield on this. See how much silver we got out of our gold plated scrap jewelry. Let's take melt it up. That water will just cook away. It only took about a minute and a half for that water to evaporate away completely to dryness. As you can see here, I am a small operation, just 10 troy ounces of silver, of cement silver here, exceeded the capacity that I have to melt it up in one shot, so I had to divide it up into 3 separate melts in order to get my bars of silver. This clip here, I wanted to show the pour of this last bit of silver, but my camera overheated and turned off all by itself, so I didn't get the pour in the footage. I'm going to add a little bit of distilled water to this container here on the stove. Now we're going to turn the heat on pretty low. I'm going to add our 3 silver bars to this liquid. And what we'll do now is add just a few milliliters of sulfuric acid. And this will remove any borax flux that we got on there. Stir that up a little bit. And let this soak for about 5 minutes on low heat. That should clean the bars up, get all that borax off of there for us. This has been on here now for about 10 minutes. And I think I've got it as good as it's going to get as far as the flux that came over on there. I think what that is some of the sodium hydroxide was left in the silver. Sodium hydroxide will dissolve silica, dissolve glass. So a little bit of the melt dish became molten and came over with the pour and stick into the bars there. Alright, here's our 3 silver bars. Alright, let's get these on a piece of paper towel, get them dried off. Get them over here to the scale. Let's see what kind of weight we got on these things. Alright, here's our 3 fine silver bars here. Got a little bit of contamination on the top of each one. I think that's some skin from the fused silica melt dishes. Put it up here on the scale. We got 295.6 grams. That's 9.5 troy ounces of pure silver. I prepared a brand new melt dish, and I'm going to take these 3 bars now and put them in this melt dish. And what we're going to do is melt this up and try to flux some of that junk off of there and see if we can pour it into a nice single 10 troy ounce bar. Here we go. I've been concentrating the flame on the dish, but now I put it on the edge of that top bar, and you'll see it starts to liquefy there and melt. And now that I've got the pretty much everything in there almost molten, here in a second you're going to see the footage speed up. I think it's 8 times normal speed. I'm going to put another shield in front of the camera lens there to shield us from the real bright light. There's the preheat torch for the mold, and you'll see me stop the flame here, and I'm going to add some flux right there, and right there. I added flux 3 different times, maybe 4, to try to get some of that skin off the top of the molten metal. And now we're just going to go ahead and pour it up into a single solid bar of pure silver here. Notice that I keep I play the flame from the oxyacetylene torch on the metal until it freezes in the graphite mold. Okay, in the next footage, you'll see me fumbling around a bit. I'm trying to get a pair of pliers to grab that 1,000-degree chunk of metal there and get it into that metal container of water to cool it off. I'm trying to shoot the video, operate the camera, and do the melt all at the same time here. And it comes out pretty decent. Here's our chunk of pure silver from the gold-plated silver refining video. Okay, here's our chunky 10 troy ounce bar of pure silver. It's still got a little bit of contamination there on the surface, and so I'm not going to call this 3/9 fine. What I'll do is I'll stamp it up like I normally do, but I'm going to call it 990. Let's see what the weight is here. We got 192.9 grams, 9.4 troy ounces. So now what I'm going to do is I'm going to stamp this up. 9.4 troy ounces, 990 parts per thousand purity. We'll put 3 tips on it and the date, and you'll know it came from this video. Pretty hard to change the looks of something like this. It's almost like a fingerprint. So let's go stamp this up now. Here we go. Picked up 3 9s and stamped it 3 9s by mistake. So I'll have to correct that. This will be an error bar. I corrected it by just stamping over the 3 9s with the large 1/8 inch 9 stamp. It covered it up pretty good. You can't really tell. But if you look at it with magnification, you'll see 2 little bitty 9s inside of the first 9 of the 990 that I just stamped on there. Okay, let's turn our attention back to the gold foils. They've been in that oven now for about an hour and a half. You see 403 Celsius, 757 Fahrenheit. So that should be enough there to have boiled off any combustible material that was in with the gold foils. They're nice and dry, nice and loose, just like we want them. So we can go to the next step, which is dissolve it in aqua regia. Now we're going to turn our attention to our gold foils here that we've nicely incinerated in our Franken oven. I'll pull up this beaker. This has been rinsed out. And I'm going to add the foils now to this beaker. Do is we'll cover our gold foils with a little bit of hydrochloric acid here. Not going to use very much, maybe about 100 milliliters or so. I'm going to add a little bit of sulfuric acid, and this is a precaution to precipitate out any lead that might be present, just a little bit. That'll mix with the lead, form lead sulfate, and then we can filter it out easily and get it out of our gold solution. Now I'm going to put some concentrated nitric in here. I'm going to start off with 3 milliliters. This should immediately start reacting and start putting our gold foils in solution. Might not even need to add any heat to this. I'm gonna put that on heat. Add just a touch of heat. I think I'm gonna put about another 2 milliliters of nitric acid in here, I guess. And that should be enough to dissolve all these gold foils in here. Alright, we've been on here cooking now for about 15 minutes. If you look under there, I can see some pieces of undissolved, looks like carat gold. Finding carat gold on gold-plated silver jewelry is kind of rare, but it's not unheard of, especially if we have older pieces in our batch. Just let this continue to react. I added a little bit more hydrochloric acid, a little bit more nitric. And I can see some stuff still on the bottom here. Looks like a piece of carat gold that didn't completely dissolve. Maybe a few stones. I'm going to take this down off the heat now and let this cool down. I've allowed our solution to settle and cool completely. Down on the bottom there, I can see some pieces of carat gold. It looks like some kind of charm. And there's some stones down in there. But what we're going to do now, I've got one of my specially prepared filters here that rides up the side of the funnel. We're going to connect the hose here. I've got my vacuum pump running. We're going to seal up the filter paper in here now. Get a good seal going on in there. And now what we're going to do is filter our solution through this filter paper. Here we go. chloride, and we'll add that to our next batch of carrot scrap. And now what I'm going to do is pour this solution here that's real cloudy back through the same filter. See if we can get some of that cloudiness out of there. Alright, here we go. Pour it back through the same filter. Now that it's loaded up, and we should be able to get some more of these solids out of this liquid. Most likely silver chloride. Okay, now we're going to rinse the filter out real good. As you can see, the solution down there is much clearer than it was earlier. I poured it through that second filter, or poured it through the same filter the second time. We can get a lot of that cloudiness to clear up. Got everything pulled through the filter now. That's what's left in the filter. And what we're going to do now is precipitate the gold with some sodium metabisulfite. Just going to pour it into this clean beaker here. This is our gold solution. Still a little cloudy, but not too bad. Sodium metabisulfite and precipitate out the pure gold. Here we go. There it goes. I think that did it. Just those 2 spoons of SMB. Right, I'm going to get a little piece of filter paper, stick it down in our solution, and we're going to test this with Stannis, make sure we got all the gold precipitated out of our solution. As you can see, 0 reaction. So that means all the gold has been precipitated. We're going to pour off the waste solution into this temporary container and get our gold out of here. About a gram or so, about what I expected. Since we had this piece of carrot gold make it into this batch, some of this probably got dissolved, not very much, but some of it probably got dissolved and will be incorporated in with the gold that we just recovered. Gold, put it in a melt dish, filter and all. And we'll melt it up into a little button. Here we go. Get the gold down into our filter here. melt it up into a little button. Here's our little button of pure gold. Looks pretty good. It's got a little flux on it. That's okay. Let's go in and weigh it up so we can get a yield on this now. All right, here's our little bead of gold. Pure gold 24K. Let's throw it on a scale here and see what we got. So we got 1.7 grams of 24K pure gold. And what I'll end up doing with this is next time I do a batch of carrot scrap, I'll throw it in with that and I'll refine it into a high purity. Okay, that'll do it for part 2 of the gold plated silver jewelry refining video. I got the metals separated. I got the gold here, 1.7 grams of pure gold, worth about now what it'd be about 80 or 90 bucks, I guess, for that little dot of gold, which ain't too bad. And now what I'll do is I'll throw this in with my next batch of carrot scrap and refine it with my next batch. And I also got a silver bar here. It weighs 9.4 troy ounces, and this is the bar from the video. What we'll do is we'll list this on my eBay store and let it go for bids. I didn't label it 3 9s, although it's probably very close to 3 9s. I labeled it 990, which is 990 parts per 1,000 in purity. And the reason I did that is because the other way to be sure that I've got 3 9s here is to run it through my electrolytic silver cell. And I didn't do that. I just melted up the silver, the cement silver that we recovered from the silver chloride conversion process. I lost a few grams. They're out there in the waste buckets, and I'll recover that material later on and get it back. But a few comments here. The silver chloride method is rather bulky. It produces a lot of waste. I would much rather put the silver laden solution into a beaker, add some copper, and cement the silver out and just let it go. As you can see, this was very labor intensive to get that a small amount of silver, and produced a lot of waste. So not only that, but if there's any other metals in with the silver, they will go into the waste solutions. And we'll have to figure out how to get those metals, the precious metals, such as platinum or palladium. We'll have to figure out how to get those metals out of the waste solutions if we use the silver chloride conversion method. If we just put some copper in there and cement everything out, then any palladium or platinum that's in with the silver will cement out with the silver. Okay, that'll do it. That'll conclude part 2 of the gold-plated silver jewelry refining. Thanks for watching.